Hello everybody, Sean here from SMD Methods. You're very welcome into this video. In this video we're going to tackle the 2019 regional qualifier for the automation discipline of the UK World Skills competition. The Task C requirement here, the problem is laid out on the sheet. We could see here that we are using TP 101 and 201 as usual for these, and we're going to use our Siemens ET200 PLC to execute this sequence here. So we can see that we have a D, a C, an A, and a B output, where it's given here that A and B are double acting cylinders, and C is a spare lamp built into a switch on the switch box, given here in circuit requirement number 4. And similarly, 5 gives that D, this one here, represents a built-in lamp integrated into the momentary switch, the start button, when the cycle starts. So we're clearly going to use a momentary switch here, a push button, PB2 most likely, to start the cycle. When I press PB2, its light will come on steady, and then a spare lamp will come on, and then we're going to start with our cylinders. Our spare lamp will go off. There'll be a 1 second dwell. Spare lamp will go on. We have another counter sequence. Spare lamp off. A 1 second dwell. Spare lamp on. A counter in which there are 2 embedded counters will execute. Spare lamp off, and then our momentary push button integrated lamp goes off at the very end. So very similar to the other 2 solutions that I had done, or the other 2 tasks that we had looked at for the regional qualifiers for this competition, is that cylinder A uses a spring return directional control valve, and B uses a solenoid return directional control valve. So again, A is a directional control valve that is solenoid actuated, spring returned, and B is solenoid actuated, solenoid returned. Cylinder B solenoids are to be controlled indirectly using relay contacts. Well, from a coding perspective, that doesn't make a difference. We're gonna light an output up. We're gonna turn an output true when we want B to extend or retract. In this case, because it's solenoid returned, how that true signal from the output card gets to the solenoid is up to the builder. So obviously it's going to go through a relay in this case, which the output from the PLC will turn on a relay coil, and then we'll be relaying what is likely to be 24 volt power through the normally open contact set of that relay to energize the coil. Each cylinder has a sensor to detect its extended and retracted position. All right, so we're going to have an LOA, LOB, L1A, and L1B. From the builder's perspective, he'll need to know, or she'll need to know, that B has to be fitted with mags, and A is determined by any of the other available sensors or switches, which in TP201 will find a photoelectric through beam sensor, a light and emitting sensor, or indeed roller switches. You might also be given an inductive or a capacitive sensor to augment the standard TP201 set of equipment. So what I'm going to do in this one is I'm going to take a copy of the sequence, and I'm going to paste it here into OneNote. So again, if this was competition, I would not say to any of the teams that I'm training to rewrite this anywhere or do what I'm doing. You would simply write your step numbers on the sheet here. So this was the last one that we had looked at, the 2023 automation one. And by the way, this is 2019 that I'm doing. 2022 I'm not going to do, because 2022 was nearly identical same as this. 2021 I believe was the COVID year, and it was an all online task, so there was no PLC. There was PLC program with it, I believe. But I do remember the specification asking for a Festo Fluid Sim solution to it. And then 2020 there wasn't a competition. 2019, yes, we're back to the 2019 one here. It was the year before. So let's add a page. I'm going to paste that in and change this to 2019 Automation Regional Qualifier. And let's paste in our circuit requirement here, or our circuit or sequence. And let's move forward with this. So What we're going to have, I have a lamp here at the very start and at the very end, so I'm not going to put that in the sequence. All right, that's going to come on when I'm actuating this sequence, which is just, I'm going to do this as one big sequence one. So at the start of sequence one, D comes on. At the end of sequence one, D goes off, just like that. But in the inside here, I'm going to put this lamp in as a step. Okay, now you could say that this is also at the start of a sequence, but because it goes off through the sequence, it has to be treated as a step unless you do split this up into three sequences, say the likes of a sequence there, and then finally a sequence there. You can put it into subsequences, but I'm not, because from the management perspective, it gets a little bit messy. So what we're going to do is I'm going to go for step 10. Now this is a counter as my next step. And within this counter, there is sub-steps, so 21, 22, 23, 24. Then I'm back out to 30 for C minus, 40, 50. Now I'm back into another counter, which is 60. And of this, I have 61 and 62. Back out to 70, 80, 90. Now I'm back into a big counter here, of which I have 100. Is this big counter. Now, when I dig into this, I can go to 101. But I'm not gonna, because this is a counter, so I'm gonna put this to 200, and then I'm gonna mine into this one to be a 201 and a I'll tell you what I'm gonna actually do. I'm not gonna put it up to 200. I'll put it up to 110. Might make a little bit more sense from a continuity point of view. 100 into this one here, 110, and then I'm gonna go out to 111 and 112. Then 110, I'm going to go this one to be 120, make this one 121 and 122, and then 100, 110, 120, 100, 110, 120, 100, finished. Go on to the next one, which will have to be clearly 130, and finish off then with D minus being the end of the sequence. Now, this is where the awkwardness, I'm not going to never call it difficulty, this is where the awkwardness appears in this sequence, right? And it's how this is managed. All right, so the way we're going to look at this one here is that when I do 90, okay, I'm going to, I'll say do a step 90. Right? After I do a step 90, right, I'm going to ask myself, have I got L1C, or this is a light on, so I'm going to say C plus. I'm going to check that I fired that output. Okay, if that's a yes, right, well, if it's a no, first off, all I need to do is wait, stop. Right, you can put in another thing there, wait for 5 seconds, a heavy wait for 5 seconds, yes, we'll put off a warning or something, but here I'm just going to, indefinitely wait. If it's a yes, right, I'm going to move to step 100. Which is a counter step, step 100. Now in step 100, what I do is I ask, is the counter complete? Right, and this one is, what counters? That's the third counter. There's the first counter, second counter. This is the third counter. This is the third counter that I encountered. So I'm going to say CNT3 complete. Is it? If that is, I'm going to have two answers here, right? I'm going to have, if it's a yes, go this road here for this one. If it's a yes, if that counter 3 has completed, I go on to the step after that main counter in the main sequence, which is step 130. I move to step 130. Okay. If it's not complete, if I haven't completed this step 100 counter, let me see if I can just hover it over here somewhere. I'm going to put a circle around it. If I have completed 100, then you move on to 130. If I haven't completed, then I go into 110. I need to do 110. So if it's a no, I move to 110. Right? Now in 110, this is another counter. So I ask, is this count complete? Right? This is counter 4. This is the fourth counter. Count 4. COMP question mark. Right? If the answer is yes, then if I've done this inside counter here, let me go to a different color again. If I have done this counter here, 110 twice, then I need to move over to 120. Let's see if we get this here. If that's a yes, then what I want to do is I want to go to step 120. Okay. If when I'm in step 120, this is another counter. So I need to ask, is this counter 5? Count 5 complete. If that's a yes, if I've done count 5 complete, if I've done that, I go to another color. If I've done this here twice, then what I need to do is I need to go all the way back out to 100. And then 100, the only way to get to 130 is by 100 sending me to 130. So if I haven't done A plus A minus, B plus B minus twice, I need to go in and do it. Then I do 110, and then only when 110's been done twice do I do 120. And then when 120's been done twice, I go back out to 100 to see have I done the whole lot of it twice. So what I need to do here is I need to move back till step 100. So let me just extend this. I probably would have been better to think about laying out this flow diagram slightly better, but I'm going to go to back to 100 and check there. So have I done, has the counter completed 3 times? No, we'll go to step 120. I'll go to step 110, which is a counter. Has that counter completed? Yes. We'll then go on to the next step, 120. Has that counter completed? Yes. Then go back to 100 and check have you done it all again. But what about the no's? So has counter 4 completed? If counter 4 has not completed, which is this green circled one here, well, if that's not completed, then I have to move to step 111. Which is A plus. L1A, have you got A plus? That's a no. Well then, your instruction is to wait. If it's a yes, then I go to 112. Step 112 is an A minus. Step 112 is A minus. So A minus, have I got L0A? L0A question mark. If that's a no, your instruction is to wait. However, if it's a yes, I'm going to go this way. Right. If it's a yes, what I do is I go back to step 110. Go back to step 110. And I'll do is just put that's my green one. Going back to step 110. Right? And then you do 110. Is that now complete after you've done all that? No. We'll then go to step 111, 112. Is it then you go back to 110? Have you done it enough times now? No. We'll then do step 111, 112 again. Go back up. Have you done enough times now? Yes. All right, then move on to step 120. Has that count completed? If it's a yes, then I go back to the other one. But if it's a no, Same way, this is counter 5, which I've done in this purple, which is 120. Right, so I'm going to move then 120, counter 5 complete. No, I go to step 121. And then in 121, I get a B plus and then a B minus. Well, 121, I get a B plus, which is L1B, question mark. If that's a no, then you must wait. However, if it's a yes, you move on to step 122, which is my B minus. So I'm going to check my input, check LOB. Have you got LOB, which is my my sensor or my switch at the B retract? If not, I'm going to wait. However, if it's a yes, right, what I'm going to do then is I'm going to go on back to step 120. Right, go back to step 120. Then I check, well, have you done all this enough times? If the answer to that is no, then you do it again. Then you go back and you check. Now, have you done enough times? No. We'll do it again. Now go back. Have you done enough times? Have I done step 120 enough times, which is the B plus B minus? Yes. All right, then go back up to 100 to check, have you done all of this enough times? The answer is no. Well, then you go into the fourth counter. Right? If the answer is yes, then you go on past it. Now that, believe it or not, is not the most awkward part of this. All right, it's just a wee bit of thinking, but if you apply the steps logically like you should, it'll make sense. The most difficult part of this one here is getting your resets right. It's getting your resets right. The resets are the difficult part in this of your counters. So let me just take a wee note here. For counter resets, my view on this, counter reset is 1, always step 0, and unless it's the very last step, finish off with the counter, it has to be step 0, and a step that is 2 number steps subsequent to the completion of the counter subroutine or subsequence if you want. I use routine just to avoid using sequence too many times. So note here, this is very important, a counter check step and a lamp actuation, deactuation, whatever it may, does not count as a step. Does not count as, I'm not going to take count out because I don't want to use count in a way that's going to confuse. Does not qualify as a counted step. So when I say 2 steps, I mean if one of them steps after the completion of the counter is a counter check step, you don't count that. You ignore that one, and then you count 2 non-counter check steps, which we're going to see here. So let's just take a note of this here, and just for learning, counter 1, right? Our counter 1 completion step, there's 20, right? 24, I'm going to have 2 counts done when I hit step 24 and A minus. Then my next step after that goes back to step 20 to check, have I done it enough? But because that's a counter check step, I don't count it as a counted step. So there's a step after it, all right? But that's a lamp. I'm not going to count that. There's my first counted step. There's my second counted step. but that's a lamp, so I don't count it. So I'm still one counted step. After that is another counter check step, which I don't count. My second non-counter check, non-lamp actuation step is this one, 61. So 40 is my first step, 61 is my second step. So counter one, reset step, reset steps. Counter one is 0 and 61. Counter two is 0 and let's check counter two out. There's counter two. 62 is going to be the end of the resets. 60 is my first step after that to check have I done this enough times, but it's a counter check step, I don't count it. 70 is a lamp going off, I don't count it. 80 is my first counted step because it's a timer, I can count that. 90 is a lamp going off, can't count that. 100 is a counter check step, can't count that. Then I go down to 110 after that, can't count that. 111 is my next one. Counter two is 111. Counter three. Oh, I'm also going to take another one here for counter two, and I'll tell you why now in a second. No, not. Counter three is 100. Normally, if I had a longer sequence here where I had maybe another timer and I had maybe an A and then a B or whatever out here, I would also reset this counter out here because after this is accumulated too, it's not going to come back in here to be reset. If I use 111, after two counts, it's not going to access 111 again. Right? It's going to be down here somewhere that it's going to want to count. Now you can use a lamp actuation, as I said, I think it was in video 1 or video 2 or whatever when we were looking at the counters. It's 9 times out of 10 that it might work, but there is a chance there that it won't work because it just actuates too quickly. The reset goes too quickly. The lamp actuates the output fires too quickly. We're not waiting for an input here. We're waiting for an output to fire in these, and they're instant. So there could be a chance that you reset your counter truly before it registers itself being done, and then you go back into it and you're stuck in an infinite loop of the counter subsequence executing and it not accumulating counts. That's what I'm trying to avoid. But we'll have a step 0 after this. At the end, and the sequence complete, we're going to move back to step 0, so that will reset that counter anyway. Now, counter 4 is the 110. So what did we say here? We were doing 0 and so 100. Right, there's nothing to do out here in 100, so it's just 0. Right. You can, if you want, if you really want to be hugely concerned about it, you can try 130 in it, this step here, but it's pointless. Counter 4 is the first internal one. These are the tricky ones now. So counter 4, right? I'm going to hit 112. It's going to hit counter 4. I'm going to go back out to 110, right? 110 is a counter check step, don't count it. 120 is a counter check step, don't count it. Then I hit 121 and then 122 and 122. Apologies, get the 1 in there. 122. So it's counter 4 is going to be 0 and 122. The counter 5, let's have a look at this one. So counter 5 is this one here. 122 is going to be the increment count. After 122 it goes back to 120. Right? 120 checks to see if it's done. Right? 120 is going to check to see if it's done. If it comes up in here and it says, right, have you done this here twice, right? It goes out to 100 and this checks to see has it been done twice. If it hasn't been done twice after subsequent to B minus, it's going to go back into 110, 111, 112. So we need to use 112 as a reset for this one here as well. You have to make sure that this one resets this. And it's odd because it happens before that counter. Usually we're so used to resetting in subsequent steps, and here we're using a step that occurs before it. Well, you are, because after this counter here, if this is not finished, this is subsequent to it, because we have this is a nested counter. Right, it's the second nested counter, which means that we're going to run this after this at least once. This is twice. The second time we don't, it's going to advance on this way. All right. So we need to put in 112 in there as well. 0 and 1, 1, 2. And what if it is a case that we don't go back to here, that we go to back to 100 and sends us on to 130? Well, we're in the same scenario then as we were with counter 100. Go out to here. We don't count that as a step. 100 says you are complete, so it moves us on ahead. This counter is not reset at this stage, but we hit 130, which is a lamp actuation, which we don't count as a subsequent step in the reset, and this does as well. This is also lamp actuation, which we don't count. So 0 is our next one, all right, which we're covered there, and that's it. So let's see about coding this. 25 minutes in, so let's see if we can get this done as quick as we can. So here is the template one that I use. So I'm gonna open up the template video, and then let's go to project view, project, save as, and let's go now for this is a 19 auto, underscore regional, and task C. I'll just keep it in there. All right, so as we do all the time, first place we go, program blocks. Let's go into the My Data block. My Data block, there's nothing fancy to do in management. In fact, we don't use any timers, any counters in management, so we can just leave that. Our inputs are fine, outputs are fine. It's all in sequence in our sequence one that we're setting up. Timers, okay, so let's have a look at what we have here. Timers, I should have actually highlighted these. I'll highlight them here now in orange. So our first timer is T1, our second timer here is T2, and our third, that's it, just two timers. Just double check that. Handy. Okay, two timers. Step 40 and step 80, and they're both 1 second. So our template has step 40. Our template is defaulted to 2 seconds. We'll have to change that to 1 second. There's timer 1, timer 2, step 80, and that is also a 1S. Just double check them. So that's it. Measure twice, cut once, 40 and 80. Nice. That's our timers done. Counters. Counter 1. So here we have five counters. So our first we have 20, 60, 100, 110, and 120. So let's go for our first one. Check step is 20. Increment step is 24. And our reset step is 0 and 61. So 0 is always in on the code. So all I'm going to do is I'm going to add 61 in here. So for counter 1, our check step was 20. Increment step was 24. Reset step was 61. All right. 20, 24, and 61. And we are doing 2 counts. And our template defaults to 2 counts. That's counter 1 done. Counter 2 occurs in 60. 62 is the increment. And 111 is the reset other than 0. All right, so counter 2, check, is 60. Increment 62, resets 111. And we're also doing that twice. There's counter 2 done. 60, 62, 111. 3, we're not going to add in any other step to reset, but what we're counting, our check step is 100. Now, the thing we're accumulating in this here is same thing here in 20. The last thing in the counter we use as the increment step, which is 24. The last thing in this counter was 62, right? Which is our increment step. The last thing in this counter here, right, not any of the sub counters, is 120. This is our increment step, 120, not 122. 122 belongs to 120. 112 belongs to 110. 120 belongs to 100. So 120 is in counter 3. I'm checking in 100, I'm incrementing in 120, and there's no additional reset step other than 0. And I need to do that twice, I believe. Twice. 110 is my next step for counter 4. 112 is the increment, and 122 is a reset. The check step is 110, increments 112, and 122 is our reset. And the function, we're running that twice. 112, 110, 112, apologies, keep doing that. 110, 112, 122. And counter 5 finally is 120 is our check, 122 is our increment, and 112 is our reset. Counter 5, 120 was our check, 122 is our increment, and 112 is our reset. And again, we have a 2 is what we're defaulted to be. Keep opening that PDF for some reason. 112 is our reset step, as well as 0, of course. All right, and that's it. So that is the sequence 1 counters, timers all sorted out. Now let's do our safety independent, which is our lights, output safety dependence. Lights, I'm going to just delete out these red greens to save some, not some space, but some considerations. I'll even do light 2 and 3, take them out. Right, so PB1, it says here, C, for C, we need to use a spare lamp built into a switch in the box. We're just going to use the PB1 light for that, the very top light. Right, that's going to be C. PB1 is C. So C, so light supply. So if not DI PB1, if this, we have these in as steps. If sequence 1.w step is equal to, now what's our step for C1? These are lamps, so we need to put these in ranges. Comes on in 10, goes off in 30, on in 50, off in 70, on in 90, off in 130. So if I'm greater than or equal to 10 and less than 30 is my first one. So if sequence 1 step is greater than or equal to 10 and sequence 1.w step is less than 130, or this one, I think the next one was, no, it's not 110. How is that? Sequence 1 step was equal to, heads away, 10 and 30, and then 50 and 70. Apologies. 10 and 30, or it's equal to, greater than or equal to 50 and less than 70. And then it was also on for a third one here as well. Or greater than or equal to 90 and less than 130. Then that light's on, otherwise it's off. Okay, so there's PB1. Now PB2 is an easy one. It says here for PB2, which is D+, which is given here. D represents the inbuilt lamp integrated to the momentary switch. Right, so we're going to say PB2, our second push button. That's our momentary switch. So that's that light. So this comes on once sequence 1 starts, and it comes off, it goes off the end of sequence 1. So for PB2, light to be steady, if not this, right? If management run sequence is equal to 1, then that light should be on. There's nothing for it to flash, else it should be off. Full stop. That's light 2 done. There's our lights done. Safety dependent, going for actuator A and B. There is no actuator C as far as safety dependent linear actuators go. A, the template gives if the actuator A is controlled by a solenoid actuated spring return valve, which it is. Let's scoot them up. So when do we want A to go out? So A goes out in 21 and back in 24. So in sequence 1, if I'm greater than or equal to 21 and less than 24, by the way, I'm just going to delete out sequence 2 and sequence 3 provisions. Or, what's our next one? 21 to 24, all the way down, 61 to 62. Now I do have another one in here, I know that, so I'm gonna Control C, Control V, or A is there, 111 to 112. Then A is true, otherwise it's false. There's A done. B. Template uses actuator B is controlled by a solenoid actuator solenoid return DCV, which it is. So for B, 20, so I'm going to do extensions. 22, 61, and 121. So 22, 61, or 121. Right, there is no sequence 2 or sequence 3 steps. Let's just double check to make sure they're right. 22, 61, 121 for B extend. 22, 61, 121. Now B retracts in the subsequent steps in each case, which is 23, 62, and 122. Right, so these are retracted. I'm going to take away the sequence 2, sequence 3 steps, and then I'll be able to remember these ones here, which is going to be 23, 62, and of course 122. Done. Okay, so there's my actuators done. Excuse me 1 second. Okay, now sequence 1's the last part of this that I'm going to code before I move into my management, which is just going to set the region. Timers done. You don't touch them. Counters, we need to fix up our counters. So why? Because what our counters are going to do is we're going to say, number one, we need to deal with this proxy bit. So for counter 1, what are we incrementing? When our check step is equal to that number, and whenever we need to check the input for what we're checking, which in this case is DI LOA for A minus. So this one goes to DI dot XLOA. All right, for the next, let's finish off this counter 1. So for our reset here, we says if we're into the value that we entered into our reset value in the my data block, or 0, which is all done. So we don't need to check anything on this. The decision, let's make sure our decision is right. We're saying that this counter is not complete. We go into what our check step is, which in this case is going to be 20, I believe. 20 plus 1, we go to 21. If it is complete, we go to 20 plus 10, which is 30. Right, which is 20 plus 1, or else we go to plus 10 is 30. So there's counter 1 done. Counter decision, counter 2. So counter 2, what are we checking here? Is we're checking 62, and we get LOA and LOB. So we have 2 things to check in our increment, not just the proxy bit, but that we have DI dot X LOA and DI dot XLOB. Everything else is done. Our decision should also be solid, because our decision here is going to put us either into 61 or 70. So if we're not finished, we're at check step plus 1. If we are finished, check step plus 10, which is good. This one will take a wee bit more work, because it's not, if we're not finished, we don't go to the check step plus 1. In this case, we actually go to the check step plus 10, brings us to 110. And if we are finished, it goes to check step plus 30 to 130. But regardless, and we also need to do what we're incrementing here. Where here we were checking 24 and LOA, here we were checking 62 and LOA, LOB. Here in 100, what are we checking? Well, here what we're going to be checking is going to be step 120, and not LOB, no. We're checking here that this has been completed. Same as this, we're checking that A minus and B minus have been completed. How do we know that? Well, it's when I get the sensor to say that A is retracted and B is retracted. Here I'm checking that A minus has been completed. How do I know that? Well, is when I check the sensor that A has retracted. Here, what am I checking? Here I'm checking that 120 has completed. How do I know that? Well, is counter 5 complete? Counter 5 complete, the Q U, or the Q decision of it. That's counter 2 is done. Counter 3 function. So it's not a proxy bit here that I'm counting on this one. What is it that I'm counting here? I'm counting that counter 5 has completed. Right? I need to check here that counter 5 has completed. When counter 5 completes, right? When counter 5 completes, I register that I've done everything in this bracket once. Right? So this is going to be into sequence data dot counters dot counter 5 dot function dot QU, because I'm counting up. Let's see, that just give me a regular Q. No, I need the QU on it. Thought that I might have recognized it as a C2U when it was specified as one down in here, but not. So keep it as the QU. The reset, right, is going to be the same because I've entered in whatever data I need into my data block to cover this and the function value. Now the decision. So if I'm at counter 3, my check step, which is 100, and I'm not complete, then I need to go till 110. Or if I am complete, I go to 100 plus 30, which is 130. And there's that counter done. Okay, counter 3 function, counter 3 decision. All right, now counter 4. I think there's something half normal. Right? Counter 4 is here, is 110. If I'm not complete, I go to 111. If I am complete, I go to 120. But I'm counting 112 and LOA. So this is going to be DI dot X LOA, because this is that's the signal, that's the input, which validates that A has indeed minused or retracted in this step. So don't forget, see that step, that increment step. That step 112, there's 2 states in 112. There's at the very start of it, A is extended. That does not mean the step is done. The step is done when A has indeed executed what this is indicating it needs to execute, which is an A retraction. I need to make sure it's retracted. So 112 and an A retracted. The reason I put in 112 is because it differentiates that A retraction from that A retraction or that A retraction. It's the A retraction that happens in 112. That's what I'm counting. That's what that's saying. The reset's fine, and all that there else is fine. Counter 4 decision, right, which is one of the standard ones. If I'm not finished, I go till the check step plus 1. If I am finished, I go to the check step plus 10. So 110, not finished, I go to 111. I'm finished, I'm at the check step 110 plus 10 is 120. Lovely. Okay. Now I need to add in a counter 5 because I don't have a 5th counter in my standard template. V. So we have 10 changes to make. We'll do them all first. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That's them all done. There's a 5th counter. So what am I counting in my 5th counter? It's LOB, right? So I'm on 120. So 120, 121, 122. Right? I'm going for LOB in my increment step. And the reason I don't need to change anything in this is because I'm addressing that to the my data block counter 5, which I've put in that detail before we did anything. It's the first thing we did before we went into the outputs or anything. We went into the my data block and we put in them parameters. And all that there is good. The decision, what do I do now for the counter 5 decision? If I am in the check step for counter 5, which is 120, and I'm not complete, I go to 121. But if I am complete, if I am at 120, right, and I am complete, I don't go to plus 10, which is 30. I need to go back to step 100. Right? I need to go back to step 100. Right? So that's hugely important. So all that's good, going to 120. But else if I'm in my check step and I am complete, then sequence data step should be equal to that. Now, I can put that in as 120 minus 20 to go back to the 100, but just to, not that I'm worried about the maths, I can just put it in as an absolute value as opposed to a relative adjustment. I'm just going to stick it straight back into 100. That's another way you could write them. You don't have to do plus 1. Sequence data step is equal to sequence data step plus 1. You can just say sequence data step is equal to 21 if you want. Right, so I'm going to put that back to the 100. So the only way I can get on to 130 is via 100, right? And that's what's checked here in 3. That's why we're plusing 30 there. All right, so that's the counters all done. Now let's do our steps. So here is grand if I'm in 0 and I'm not complete, and A is back and B is back, and we could even say if C, don't say D is not on because D isn't part of our sequence anymore, right? D is it's not, it's the prelude to the sequence coming on, right? I could say and not C plus, right? Which was the and not DQ. So this is going to be an outside light. XL, it's a light that I'm looking. That's the PV1 light we were saying. Right? It's the PV1 light because don't forget D plus was the PV2 light. C plus was the PV1 light. And not that, then I'm into sequence step 10. Now if I'm equal to sequence step 10 and the light has come on, and PV1, the reason why sometimes you have these double quotes and other times you don't, right, is that flipping hyphen. I don't know why I have that hyphen in there. I would usually put in an underscore, right? So I don't know. You can call it a special character if you like. If you have a special character, it puts the string in. Put in an underscore, you won't have that. Okay. But anyway, let's keep going. And then the light comes on and move on to step 20. Now, if I'm equal to step 20, 20 is going to be my counter. So I'm going to say that I've already dealt with it in my counter section. I'm either going to go to 21 or I'm going to go to 30. So let's assume I go to 21. So if I'm equal to 21, so I'm doing an ABBA here, A, B, B, A. So 21 to 24 should be laid out for me. If I'm equal to 20, then I'm going to go to 20. Now, if the counter up here has put me to 21 and di dot x L1A, A goes out, then go on to 22. If I'm equal to 22, now B goes out, X L1B. Then you go to 23. Put these down here because I can take them out at the end. Right, now I'm going to take these ones here, which we'll see 2 of them because there are 2 more steps. If I'm equal to 23 and I get LOB, then you go to 24. If I'm equal to 24 and I get LOA, right, then I go back till 20, go back to the check step. And the check step will either put me into 21 or it'll put me into 30. So else if it has put me into 30, what do you want to happen? So if it's put me into 30 and not LOC, then I go on to 40. So if I'm into 30 and not, this is going to be a DQ dot XL PB1, then I'm going to move myself on into 40. And in 40, I go on to my counter. So there's the 40, I go to T1. So I did delete out my counter already, so I'm going to have to rewrite it again. So if I put me into 40, and then I go into sequence data, sequence data dot timers dot timer1 dot function dot q goes off, then I go on into 50. So in 50 then I get C to go on, so I'm kind of up to the start here again. So what I'm going to do is take So young ones there shouting away. I'm going to take it from my lights here again, and I'm going to take that timer because I'm kind of repeating sequences, so I'm going to try to take it from there. Then I make it a 50. So if I make it a 50 and my light has come on, then you go on to 60. 60 is my next counter, so it's going to put me to 61 and then 62 and then back to 60. So if I'm equal to 60 and I get L1A and L1B and di dot x L1B, oh sorry, 61. 60 up, my counters will put me into 61 or it'll put me on to 70. If it has put me to 61, I get A and B out. Then I go to 62. If I'm in the 62 and I get, let's keep them in order here, and di dot x LOA and di dot x LOB, A and B both come back, then put me back to 60. And then 60 will either put me back into 61 or it'll move me on into 70 again. So I'm going to take off all of these to here. And I'm back to this. So now if I'm equal to 70 and the light has gone off, then take me on into 80. If I'm equal to 80, if I'm 80 and timer 2 has completed, I go to 90. If I'm equal to 80 and timer 2 has completed, then take myself on into 90 and I'm back to my lights again. So in 90, my light has to come back on. So what I'll do is I'm just going to paste again where I was. Right. So if I'm equal to 90 and my push button light has come on, then I go until 100. This is my counter again. So 100 was going to kick me on into 130 if it is complete, or into 110 if it is complete, or it's not complete. So I'm going to imagine here that it's put me into 110. Right. Right. So if it put me, apologies. So if it put me into 110, I go into my other counter. So my other counter is going to say, right, if you are complete, I'm going to move you on to 120, which is another check, or I'm going to put you into 111. So I'm going to say here, imagine you put me into 111. What happens? So in 111, I get A plus and then I get A minus. So if I'm equal to 111 and A plus, put me there to 112. If I'm equal to 112 and I get A minus LOA, then I needed to put me back into 110, into the check, right? So if I get 112 and LOA, go back to 110 to see if I've done it twice. Right? If I haven't, 110 will put me back into 111, and then it'll put me back into 112, and then I'll go back into 110 to check. And then if it has done, it'll move me to 120. Counter check, counter 5 will check. Have I done 120 twice? No. Then it puts me into 121. So I'm going to start here with 121. Oh, sorry, I shouldn't have started there. It stays at 110. Goes back to my check. Now I'm going to start here at 121 and L1B, because in 121 B goes out, and then 121 L1B puts me to 122. If I'm into 122, it's then what I wanted to do. Then 122. If I'm in 122 and LOB, B goes back in 122. Then I need you to put me back into the check step, which is 120. Then sequence data goes back into 120. Then 120 will check, have you done that twice? If you haven't, then it goes back to 121. If it has it done twice, it'll go back up to 100. 100 then will dictate, should it go into 110 to check or go on to 130. Okay, so now we're going to assume here that it's gone on to 130. C goes out, 130 and not C goes out, then I go to, and if it has gone out, then end sequence at 130. And not functions can come out. take it all the way down to then sequence is complete. And that's it. So what I'll do is I'm going to X that, X that, X that, X that. Check in your main OB. I don't see anything obvious with errors showing up. Falls good. Click onto your PLC folder, hit compile. Check to make sure you only have 3 warnings if it's the first time that you've compiled this after saving the project. And again, the 3 warnings will be associated with the security settings on this, protection levels, unsecured communication, and so on. Every subsequent time, I always say it, that you compile it, them warnings won't show up. That's all good. Let's save that. And let me just plug in an Ethernet. If that's all good, then let's download that into the PLC and just make sure that that will also work. Okay, start search, and I'm looking for 200, which is there. Load that. We're going to have to synchronize, load, finish. That's it, done. Save. All right, job done. Right, so there I can compile again after I've done that. If I compile, there's the warnings away. All right, nice job. So that is the 2019 solution done. Again, I haven't tested it, so maybe there was an error. Maybe when I cut it and pasted a couple of things, I was a little bit hasty. I don't know what the time was to work that solution out. I know the video here is just coming up to under an hour. There was an awful lot of explanations going on this and an awful lot of writing that you naturally wouldn't do during the competition. This was a 60-minute task. We are still under 60 minutes, including all this, so we definitely would have had it done in the time period. And of course, this hasn't left time, and I'll never call it debugging because it's not debugging. It's rectifying errors. If it doesn't work, when you've downloaded this in the PLC, it's not a bug, it's an error. So we haven't left any time there for identifying errors that we might have made and for also rectifying them. But we haven't done, sorry, getting too hasty looking at the time. I haven't done my management block. There's a big error. So the only thing I need to do on this one is, because I have this in, I'm going to have to put in provision to switch on e-stop and the safety light curtain. So I'm going to write them up here earlier. I'm going to say di.x e-stop is true, and also, geez, very sorry about that, xslc is also true. I'd be there pressing a button, nothing happening, scratching the head. So there we are, they're true. Now, they won't have any effect. What we need to do is we need to go into the CP interface and set them true there. Inputs. So here, I'm going to just say that they are true and true, as opposed to looking at the pins on the input card for a signal. I'm just going to say ignore them and just take them there that they're always going to be true. That's that one and that one. Safe status first scan is fine. Initial conditions are fine. That A and B are true retracted. Our sequences all should be good. All right, sequence 1 is the only one we're worried about. So management run sequence 1, and when I'm complete, reset everything. To start the sequence, the only condition is for me to be in run mode 1. So let's go into run mode 1, into modes. Region, how do I start run mode 1? So if I'm run mode is equal to 0 and I press my PB, my push button, which I am, my first push button PB2, then I move into run mode 1, which is all good. That's it, it's only for starting. Let's just make sure at the end of the sequence 1, I also put my run mode back to 0. Management run mode goes to 0. Yep, so that should be it. So in hindsight, there was very little to do in that except turn on my sensors to indicate, to indicate that the system is safe. Back to main OB. All is good. Sean's PLC, compile, 8 seconds, all good, and download. 3, 2, finish. There's 1 hour exactly. So yeah, we still got it done in another 60 minutes, even though we had that hiccup at the very end. And again, we haven't checked it for hours, but hopefully everything should be okay. Yeah, so thanks very much for what is a longer video than the last few, but we did have a little bit of additional explanation with the counters that I hope might help you out with getting your head around how I set up the counters, and yeah, if it's something there that you think that you could employ, adopt, and use yourself for benefit, absolutely use it and spread the word. So yeah, hit a subscribe there as well for me, please. And whenever the next videos come up, you'll be notified. In the next ones, I'm probably going to step away maybe from automation a little bit, and I'm going to go into the mechatronics regional qualifiers. In that, at a regional qualification level, there's very little difference in the automation and the mechatronics with respect to the equipment being used. The mechatronics might bring in a third actuator that's not a light, might be more to do with lights, more sequences running, and then of course it'll always have, or it has had in the last couple of years, the lovely IO link devices. So I'll do a separate video there in configuring an IO link devices. The first video in the series on developing the template set up the CM module card, which is a communication module. For the IO link, but what we'll do is we'll actually configure it using an IODD file for a ball of light, or maybe a warmer light, or maybe some Festo pressure or airflow equipment or something similar. But yeah, it'll be fun. So yeah, hit the subscribe, and whenever them videos start coming up, you'll get notification of them. So as always, thanks very much for joining, and yeah, I hope you stick with me and come on into the next video. Thank you.